Okay, moving on. Last talk for the evening. We have Randall here. Randall Lin is an ML engineer at Fathom Health. He previously studied physics and computational neuroscience at Caltech. Before Fathom Health, he worked at Halo Neuroscience.
Yeah, so I'm here to talk about Airbender, in-house tool. Enables us to isolate developer working environments while we work on Kubernetes and Airflow. So who are we? At Fathom, we use machine learning and NLP to standardize physician notes for medical billing. I'm Randall, and here's our tech stack. We do everything on Google Cloud. Everything is run on Kubernetes, scheduled through Airflow, and then everything is in Python, which is important to note just because everything will be interpreted. So that lets us do certain things we get away with. So our main goal here is to make development easy and fast. And in the spirit of that, we want dev and prod to be equal almost always. And also as a machine learning shop, we experiment a lot. And as a side effect of experimenting a lot, we also run our pipelines a lot, rerun them a lot. And we do this on multiple versions of the pipelines or the tasks. And to do that fast, our DAGs have to reflect the latest commit on that branch for fast iteration. And as we're dealing with medical data, security is also of utmost importance. So our solution is Airbender, and it addresses the problems. It isolates our Airflow work environments. On demand, you can spin them up, put them back down, and they're tied to specific GitHub branches, isolated in Google Cloud Storage. Your code and your secrets all synced. And so here's the user experience for the developer. Make sure you're on the branch you want to be doing things on. Then all you do is run Airbender up. You name your namespace that you want to be doing things in. And after a few minutes, you'll have an IP you can go to, and you'll have your DAGs. And two things to note, the code changes will just be immediately available to the tasks because they're just spun up as they're run. And any DAG structure changes are dependent on Airflow, just refreshing the DAGs. And let's say you're experimenting things, maybe you have another branch you want to run, the other run's going, do the same thing, just change branches and spin up again. And when all is said and done, everything's run, results are good. You want to bring your environment down, just Airbender down, and it'll delete all the Kubernetes resources that you've been using. So that all seems easy, but behind the scenes, what's happening is as you run Airbender up, it's a local Docker that defines your Airflow pod spec, chooses your Git branches, decides if you need OAuth, if you need firewalls, then that passes it to GKE and creates your Airflow pod in the specific namespace you've decided on, and also syncs your code. After that, the load balancer, you ask it for the IP, and then you can add it to the DNS for a subdomain of your Airflow that you as a developer are working on. And then our secret syncer deployment on GKE will push the secrets to all the namespaces so that your service accounts are always up to date. And as a developer, you can just, using that URL or IP address, you can hit your web server. And how does the individual tasks, how do they get run? Three things happen when you run each task. Service account is chosen so that the permissions are minimally permissive. GitHub branches are mounted to the new containers that are spun up, and IO is isolated by every DAG is a unique GCS workspace path. That way all the files going in, coming out are under that workspace. Certain gotchas that we ran into, two main things. One is being able to sync your code is a blessing and a curse. So you might be changing your DAG structure and all of a sudden you had something running and you sync to, you change the DAG and now they're orphan tasks. But that's pretty easy to revert. You can just, sync again. Dev being close to prod is also good, but that makes devs want to iterate remotely on Airflow. So that's going to be still inherently slower than local iteration. So, certain to-dos we have there, like Minikube or other things. Yeah. Questions?
Is the database shared with?
No,
does it have your own?
Yeah, it's not like Cloud SQL or anything. Yeah.
This is
So it's on one node or on one pod, but it's like each container. Yeah. Yeah.
yeah. This was totally sweet, by the way. This
Oh.
presentation.
Thank you. Yeah.
I guess how much constraints do you put on your actual business logic code within the tasks in order to? You said you had to do like namespacing and GCS. Do you like have APIs in your actual business logic code so that you like have to actually use that namespace? Because Airflow is just arbitrary Python, right? So it could touch whatever external resources you want.
Yeah. So I mean, it's a combination of like the namespace, the DAG ID, runtime, but that's all handled by this wrapped like, go get stuff from GCS function we have, and it'll just look in your environment variable, and it'll know, you're in Airflow and you're doing certain things, and it'll inject those directories.
So you just have a bunch of internal APIs, and then because you're good at stuff, you just remember to use them.
Yeah.
Everything's ephemeral, right? So that's for like one-offs. So if you wanted to schedule something every day to run every day for the next year,
it's a little different. Yeah.
Then you go with more classic.
Yeah. The typical use case is like, we're going to explore all these models, or one crazy use case is like tensor, broke some of our things and we wanted to get bisect, but the whole pipeline, right? And so just spin up like a bunch of these and see what's happening. Yeah. Yeah.
This was awesome. I just wanted to say that too. I have a naive question. Well, first of all, how long did it take you to glue all of this?
Well, we're still working on it, but I'd say between me and the other guy, it's several months. Yeah, and I mean, we're still always adding and picking up bugs. So yeah.
So the naive question is, why not go the other way, which is just multiple Google projects, multiple clusters, and you don't have to do the namespacing side.
Well, so it's dev dependent. So I guess, yeah, if you're in a world where you're giving each dev their own project for whatever they're working on at the time, that might work. Yeah. Yeah.
For the repo. Where's the repo?
We don't. It's not released yet, but yeah, we're certainly open to. Okay. Yeah, working on it.
Awesome. Thank you.